Using graphs and tables, verify whether or not f of x equals x minus 1 squared and g of x equals negative square root of x plus 1 are inverses. If the domain of f of x is restricted to the set of x's such that x is greater than or equal to 1, including checking the domain restrictions. So let's first just draw in our domain restrictions on this graph. So we see that x has to be greater than or equal to 1. So we can just make a dashed line here when x equals 1. And we know that our domain is on that line or to the right of it. And so let's go ahead and answer some of the questions about domain and range, and then also looking if it's a reflection of the line y equals x. So first of all, just looking at it for the reflection part, if you were to fold over this graph on the dashed lines, would f of x line up with g of x? And it definitely appears that no, they are not a reflection across this line. So that shows it will not be an inverse. And then the other thing we need to look at is domain and range. And so just notice that both will start at x equals 0 and also y equals 0. The f of x will go up from y equals 0 and the g of x will go down to negative infinity from y equals 0. So let's just write in those domain ranges. And again, we just saw no, it's not a reflection of the line y equals x. And for the domain of f of x, we saw it goes from 1, which was our domain restriction, all the way to positive infinity since it keeps going right. And then the range is going to go from 0 and then all the way up to positive infinity since it goes up. And then with g of x, it has the same exact domain since it starts at 1 and also goes right to infinity. And then it starts at 0 and goes down to negative infinity. So we go least to greatest, negative infinity to 0. So with the inverse functions, then the domain of one should match the range of the other and vice versa. And we see here that they do not. And so it's not going to be an inverse function here. And then I just want to point out with the x and y intercepts here, notice that the x-intercept of g of x and f of x actually, but I'll just say g of x for this point is 1, 0. And then notice that the y-intercept of f of x is 0, 1 on the x-axis. So just noting those, that actually is the property of an inverse. So if our domain was a little restricted and if x was less than or equal to 1, then it would be inverse functions based on those points. So I'm just going to point that out, the other point on the graph. So again, there's 0, 1, 0, and then 0, 1. So if we could go back, then we could have inverse functions there. Okay, so let's go on and look at the tables. So now we just want to compare the tables, and we want to know for every x, the y that we get out, if we then put this y into the g of x table, will we get out x again? So let's start with 0. So we get 0 minus 1 squared. 0 minus 1 is negative 1. Squared is just 1. And then we continue here. 1 minus 1 squared. 1 minus 1 is 0. Squared is 0. 2 minus 1 squared. 2 minus 1 is 1. Squared is 1. And 3 minus 1 squared. 3 minus 1 is 2. Squared is 4. And I'm not going to do the rest of these rows. You do this exact same process, but just for sake of time, I'm going to keep going. So now we take our output from f of x and we're going to put it in for our input on g of x. So we have 1, 0, 1, and 4. So now we plug it into our g of x equation. We get negative square root of 1 plus 1. Square root of 1 is just 1, and so that's negative 1 plus 1, which is 0. And then if we plug in 0, we get negative square root of 0 plus 1. Square root of 0 is just 0. Negative 0 is just 0. So we get 0 plus 1 is 1. 1, we did that in the blue row, so we get 1. And then 4, negative square root of 4 plus 1. The square root of 2 is just 2, so we get negative 2 plus 1 is negative 1. Okay, so notice I did the top row in blue there because 0 is not in our domain. I've simplified these values in our in these two tables. And so looking here, we do see that 0, 1 and 1, 0 are inverses. And same with the next one, 1, 0 and 0, 1. But after that, 2, 1, 1, 0, 3, 4, 4, negative 1, and so on, they no longer become xy and then yx pairs. They do not have an inverse relationship. So we see that in the 0 when x is 0 or 1. So again, if x is less than or equal to 1 for our domain, then we see they actually do end up being inverse functions. So let's look at our final answer. Our final answer is no, f of x equals x minus 1 squared and g of x equals negative square root of x plus 1 are not inverses because their graphs are not reflections of one another and the restricted domain and range of f of x are not the range and domain of g of x. If the restricted domain of f of x had been the set of x's such that x is less than or equal to 1 instead, then the functions would have been inverse functions.